Here's our next lesson on inverse functions. So inverse functions means finding f of negative 1 of x. So if they ask you to find f to the power of negative 1x, they mean find the inverse function. Remember, inverse function means you swap the x and y around, rearrange to make y the subject, and then express it in the form of f minus 1x equals, and write your answer. So remember back to our logarithms unit in year 10. We did a few little inverse function questions there. So in exercise 31b, question 1, this is like basically from your logs booklet. In exercise 31b, question 1, you were asked to find the inverse function, or asked to find that, for a variety of exponential and logarithmic functions. So just reminding you of what it said back then in that year 10 booklet. To do this, you first just swap around the x and y, and then you rearrange or transpose the formula to make y the subject, like what you did for the transposition questions in the transposition unit last year. So find the inverse function, or they might have just said find that, for this one. F of x equals 4 times 5 to the power of x. So remember, f of x just means y equals 4 times 5 to the power of x. So to start to find the inverse function, once you've written it as y equals, just swap it around, make it x equals. Swap the x and the y around, 4 times 5 to the power of y. And now we just rearrange this blue function and make y the subject. So before we take the log of both sides, we need to divide both sides by 4. So x over 4 equals 5 to the power of y. And now what we can do is we could turn it into log form, like we can go log base 5, x to the power of 4 equals y. Or we could take the log of both sides. I'm going to happen to turn it into the logarithmic form. So remember, to turn it into log form, you just write log. The base is 5, so 5 goes here. The answer is x over 4, and the exponent was y. So remember, log base 5, the base goes down the bottom of the log. X over 4, some people like to put a bracket here, it's fine if you do or don't. Bracket does make a bit more sense. Equals y. So you've already got it in the form of f minus 1x. As soon as you've got it in the form of y equals, you're done. But the examiners really like you to write this final step, which I'm doing in green, is to just rewrite that in the function again, log 5x over 4. And instead of writing equals y, write it as f to the negative 1x. Really important final step. Please don't skip it because it's such an easy thing to do, and you really don't want to lose marks for not having done that. Next one again. F of x equals 4 log 7x. So let's rewrite it. Y equals 4 log 7x. Let's divide off the 4 first. Oh no, I need to swap everything first, don't I? So let's do this one all in purple. So instead, x equals, swap the x and the y around, log base 7 y. Now to solve for y, you could try putting it from log form into exponential form. In the previous question, we put it from exponential form into log form. In this case, let's change it from log form into exponential form. So to remember the base, oh no, sorry, we need to divide off 4 first. So divide both sides by 4, just keeps it in the pure log form. We've got no coefficient out the front. So now we've just got the log by itself. Now we can turn it into exponential form. So like the base is 7. The exponent would be x to the 4. So remember, converting between log and exponential form. Base 7, the exponent is x over 4, and the answer is the y. So we're almost done. We just need to replace the y with f minus 1x. So don't forget to do this nice final step. 7 to the power of x over 4. There we go, and that's our inverse function. Don't forget, don't leave your inverse function written as y equals. Write it as f to the negative 1x. And let's do some more. Find the inverse functions for the following. So same thing, just write it as y equals to start with. Kind of just helps you kind of have this kind of procedure, and then swap it over. So that's the original function. Rewrite it as x equals y squared minus 2. So x equals y squared minus 2, and now we rearrange to make y the subject. So you might guess add 2 to both sides equals y squared, and then take the square root in order to get y by itself. Because the opposite of squaring is to take the square root. And then rewrite the y as f to the negative 1x. that's what officially you were asked to find. It's important to write your final answer like that. Okay, so f to the negative 1x equals square root of x plus 2. And then that one's done. And now the next one to do is to go write it as y equals, and then what we need to do is swap the x and the y over. So x equals square root of 3y plus 4. And then we start to transpose. So the opposite of square rooting, what's that? That's right, it's squaring. So x squared equals 3y plus 4. X squared equals 3y plus 4. So x squared minus 4 equals 3y. So x squared minus 4 divided by 3 equals y. Don't forget your final answer. Rewrite it as f minus 1x equals x squared minus 4 over 3. Definitely feel free to pause and just try these ones by yourself and just check your answers with what I've got. And I've got another few examples here. This one I've given you a hint that you might need to use logs. So let's write it y equals 2 to the power of x. So now first step, swap it over. X equals 2 to the power of y. And when we've got we want to re-transpose to make it the exponent, the answer, we just turn it into logarithmic form. So our base is 2, so it's log base 2. Our answer is x, and the exponent is y. And then the final step, just make it f minus 1x. Log 2 of x. And done. So we've got it in the form of y equals already. Next one, again, feel free to pause, try these yourself, and just check with my answers. Recording video. So then y equals negative 4x plus 1. Negative 4x plus 1. And then what I've got here is x, swap them around, x equals negative 4y plus 1. And then what we've got next is we've got to rearrange to make it y equals. So we've got to subtract 1 from both sides, because negative 4y, oops, we're getting a lot of people trying to get in the room at the same time. So x minus 1 equals negative 4y. Then you might want to go x minus 1 over negative 4 equals y. So we can rewrite that as f to the negative 1x equals x minus 1 over negative 4. Or we could rewrite it as, that's not wrong if you had, you multiplied the top and bottom of the fraction by negative 1. Multiply the top by negative 1, it'll become positive 1 minus x and over 4. So technically those are the same answers. If you multiply the top and bottom by negative 1 from the left hand side, you'll get the right hand side answer. So just in case some of you had the right hand side answers and were worried you had it wrong, that answer is the same as the one that I had originally. Now let's do this as soon as quickly before I have to run to a meeting. So y equals 1/3 x minus 7. First step, swap the x and the y around. X equals 1/3 y, subtract 7. First step, let's add 7 to both sides. X plus 7 equals 1/3 y. Let's multiply both sides by 3 is what I would do next. So 3 x plus 7 equals 1y, or you can just write a y. It's a 1y. And then, so expanding that, you'll get 3x plus 21 equals y. And the way we write our final answer, f to the negative 1x equals 3x plus 21. That's our inverse function. And our last one here. So we write it, y equals 1 minus 3x over 2, and then maybe in a different colour, let's swap them over. X equals 1 minus 3y over 2. Multiply both sides by 2. 2x equals 1 minus 3y. You might like to make the y positive. If you want to do that, you can go 3y plus 2x, or 2x plus 3y equals 1. So 3y equals 1 minus 2x. So y equals 1 minus 2x over 3. So our final answer is f to the negative 1x, which equals 1 minus 2x over 3. If you hadn't have swapped, like made the y positive before, you might have had a slightly different answer. You might have had, oops, not that, or that. You might have instead have f to the negative 1x equals, you might have had instead 2x minus 1 over negative 3. That's also correct. Both answers are the same. Basically, first one, if you multiply the top and bottom by negative 1, you get the other answer you have on the right. On this page, we've kind of got some examples of how you use composite functions in the real world, like from the previous lesson, composite functions. So I'll give you the chance to read through that in your own time, just so you can see some applications of composite functions in the real world, like, for example, insurance, other kind of things. So we've got traffic, time, that kind of thing. Anyway, just to save you time, I'll kind of stop the video now.